Okay, let's get started. Happy Thursday, everyone. This is Soroban Design Discussion, an open protocol meeting in which we discuss design decisions for the Soroban Smart Contracts platform to be launched very soon. Today, we're going to be talking about state expiration. So, without further ado, I'm going to hand it over to Garand.
Yeah, I know we haven't talked about state expiration in a second, but I think before we were kind of talking high level what the interface wanted to be, and then now we're actually starting to implement pieces of it. And so, kind of the timeline for this is first we're going to start charging for rent on FutureNet, but not actually have any penalties for a rent balance of zero or negative, just so that we can make sure that the rent is being charged correctly and all that sort of stuff. Next step will then be to add ways to a bump rent, but again, still with no consequences on FutureNet. And then once we have the rent bump and the rent charging correctly implemented, we'll actually enable consequences. And essentially, what that means is that an entry will need to have a non-zero or non-negative rent balance to be usable. But we still won't actually be sending entries to the archive and deleting them from the ledger for some time still. In addition to that, once the rent system is in place, we'll then roll out temporary entries, which are the entry types that have a TTL that expire after a certain amount of ledgers. And this TTL is variable. And so I know we've talked about kind of like at a high level, but we're actually starting to implement this rent stuff. And so there's a couple of open questions, both in the rent proposal and in the temporary storage proposal that we want to talk about in detail. So when we initially talked, we didn't have automatic rent payments on access, and this was an implementation issue with the way the bucket list is structured. However, now we've changed the way in which we actually record rent balances on Ledger, and so we can bump rent on every access. And so with that in mind, we've changed the way that we structure rent payments. How it currently looks is every data accessed in a smart contract call receives some small baseline rent bump. This isn't expected to be a very large rent bump, but just something small and automatic. Now, this includes not only contract data that's accessed, but also the contract instance itself and also the contract WASM code. And so this also allows you to bump the smart contract itself and the smart contract code without needing any extra intervention or anything. And because this is a small incremental bump that's bumped automatically, it means that smart contracts and entries that are used frequently don't really need to worry about rent. Something like USDC that's used every day will have enough rent balance via these automatic bumps to never have to worry about doing a manual rent bump. And so this automatic interface is a lot easier and covers a lot of the weird cases in UX kind of pain points that we were seeing before when we didn't have these automatic rent bumps. Now, the open question here is with regards is what do we want to do to, in addition to having these automatic rent bumps, what interface do we want to expose for the quote unquote manual rent bumps? And so we have two kind of fields of thought here. So what a manual rent bump is say you have an entry that's not accessed very often. Say you have like a token balance that you only use every 6 months or 1 year. But when you use it, you want it to be accessible very fast. And so you want it to be not in the archive and remain on the ledger. So automatic rent bumps are not sufficient for this use case because you're not accessing it very often. And so the automatic rent bumps aren't large enough to keep this wallet or this token balance on the ledger. And so we want an interface where a user can do a explicit manual rent bump. And instead of doing the small incremental rent bump, say I want 6 months or 1 year or 10 years or something like that of rent for this entry. And so kind of the two ways to do that are either A, via a manual operation, where the invoker of the operation specifies the set of keys that they want to bump. And so this is the most manual approach, but it's also has some benefits. One of the significant drawbacks, though, is that the user calling this function needs to know what key belongs to them, which isn't always easy. So, for instance, in a token contract, you may be able to have just one entry and one key for each user's balance. That's relatively easy to discover, like whatever my balance key is on USDC. But there may be other entries that are also associated with your account in addition to that balance entry. So, for instance, a token contract may also have a nonce that's required to do transactions with your token balance. And if a user only knows about the token balance ID, but doesn't know about the nonce ID, they may pay a bunch of rent on their token balance and have that active on the ledger. But then in 6 months, when they want to do their transaction, they didn't pay rent on the nonce entry. And so they still have to wait to get the nonce value out of the archive. And so one approach to this is to allow the contract to define rent bump behavior. And we do this by exposing a rent bump host function to the smart contracts. And what this allows contracts to do is to codify on the contract itself rent bump behavior in addition to the automatic rent bumps. And so in our token contract example, say that there is both a rent balance and also a nonce that are have separate keys. Now I'm not saying this is the most efficient approach, but this is an approach. And so what the contract could do is it could define a bump my account function. And this bump my account function will use the host function to bump both the token balance and also the nonce value associated with the user. And so in this way, the user can just call the bump my account or bump my account function, and then bump their account by 6 months, a year, the specified amount, or however much is codified in the smart contract. And this allows the smart contract developers to abstract away a lot of the rent interface to the user. And so the user still can bump rent manually, but doesn't need to know exactly what entries belong to them, exactly what keys belong to them. So it's a significantly easier user experience. It also allows the contract to define some sort of automatic rent bump behavior in addition to that supplied by the protocol. So for instance, the protocol might say, bump every access by 10 ledgers worth of rent. But then the smart contract developer might say, oh, for my use case, I want to automatically bump by 100 or 1,000 ledger entries. And so they can use this rent bump host function to define additional rent bump behavior in addition to that automatic rent bump that the protocol has. Now, even the benefit is that this can provide a better user experience, but this opens the door to either malicious griefing or just accidental overspending of fees. This is kind of dangerous because it allows the contract to define arbitrary rent to take from the user's transaction fee. And so this can't be gamed in a malicious way because there's no financial benefit to paying a bunch of rent for other entries. Like there is no way for the attacker to steal rent fees in any way. But this could be a griefing aspect where a contract call could say, pay 1 year rent for all of these unrelated entries that aren't important to you, but still take that from your refundable fee. Now, again, code audits could catch these attacks, but it could be very difficult because, for instance, they could name an entry such as they could give an entry a inconspicuous name like auth entry, and have every call pay 1 year of rent to an auth entry, where it could be actually a different entry type that's used maliciously. And so, even though exposing this host function could provide a better user experience, it also opens the door to these kind of large fees that contracts can define. And so I guess that's our first open question is regardless of if the host function is accessible via smart contracts, it will be accessible as a manual operation call, regardless. And so the question is, do we want to just have that manual operation call where the invoker has to specify every single key to bump? Or do we want to also open up this host function to the smart contracts and allow smart contracts to define their own rent bump behavior?
I have an opinion on this that I wanted to talk about while everyone is thinking, because I've been thinking for some time about this, and I'm really biased towards just doing a single host operation that is invoked in a standalone fashion, and not go with contract-defined bump behavior, at least for V1, because as Grant has mentioned, there are really a lot of issues with how this can be misused. But also really, even if you think about the UX aspect of it, like we are talking about some abstract user here. I'm not sure it's an abstract user who does the bump. It's rather some program in between that does that, which is probably a wallet, right? And for example, if you're talking about the token balances, I don't see any significant technical difference between implementing bumping your balance entries rent via a separate operation or via a separate contract call. It's something that needs to be coded in the wallet interface, right? And then provided to the user, like, hey, you know what, your entries are about to expire. And another thing is that I really don't think there are too many entries that users should ever care about bumping them. So I'd say this must be just balances and NFTs, and even if you have this ledger key-based approach, it doesn't seem overly complicated to have support for them and have some basic library that just builds the correct bump transaction for a given contract interface, for example. So I don't see this as a big UX issue, but I do see a lot of issues with exposing this to the contracts, and it just doesn't seem like a super straightforward feature to communicate like how contract developers should use it. Like I don't think we have a good strategy for this now. So yeah, that's my opinion here.
It feels a bit or slightly inconsistent, the fact that the current storage model definitely encourage access through host functions rather than directly through like ledger entry keys. And so to have this additional system that does encourage access directly to the ledger entry keys, that sounds a bit inconsistent to me.
Well, we cannot abstract ledger access away, right? You like the dApp developers still need to care about the ledger footprints, and basically rent can be inferred for them. Like some ideas floating around were like maybe allow to specify bumps on the footprint, for example, or as a parallel entry to the footprint, so that you can do this at transaction level. Basically, I think the main question is whether we put this responsibility on the contract developers or on the entity that builds the transactions. And I'm saying that probably it should be on the side of whoever is paying for the transaction, right? Because that's them who are paying the rent. And really, for a lot of contracts, there is no single strategy the contract writer can realistically define in terms of how the bump should be defined. Well, kind of seems tempting to do that, right? But in the end, it's the entity that pays for the transaction who needs to decide what to do with the rent bumps, if do any bumps at all.
Right, but it's the contract developer that has the full understanding of what in the contract state actually relates to a specific account, right? So where will this information be captured?
Well, yes, but I'm not sure like it needs to do anything with the bump balance. So I can see the functions that just expose the entries that need to be bumped, but I'm really concerned about just doing the bumps themselves from the contract. Like having some metadata that says, hey, you need to bump that for a given address is fine, but fully programmatic access seems to be able to do much more, and a lot of this doesn't seem like the right thing to do. Most of the time, like bumping for thousands of ledgers when this might not be a user intention, and this just creates some pretty confusing UX for the contract users.
Garand, question. So I do like the concept that the end user, or no, I should say the smart contract author can write his own function to modify the default behavior. I think that's great. I'm a little bit concerned that the smart contract developer would need to write that method. That's something that I kind of not feel very comfortable around, because it guarantees user errors And ideally, if we could do anything that would provide out-of-box experience where it would just work, then it would be much better. Even if the just work wouldn't be the optimal solution.
Well, I think in either case, whether we expose the host function or not, it will not be necessary to define the sort function because we do have the protocol floor automatic bump rent, which happens regardless. And so this is just for if you want, in addition to the automatic small incremental rent payments, do you want additional control over how you bump? And I also want to clarify that this doesn't overwrite the default behavior. The default behavior will happen whether you use the host function or not. So say like for instance, just for an example, the default behavior is to bump every entry by 10 ledgers worth of rent. If you also, in addition to that, say use the rent bump function to add another 100 ledgers worth of rent to a token balance, the resulting rent bump would be 110. The 10 ledgers that were automatically bumped and the 100 ledgers added on top of that by the host function. And so your answer to your question, the automatic rent bump interface attempts to kind of give the best out of the box solution as possible, with the thinking being that the most accessed entries will have the most rent and be the most readily available. And so this is an addition to that default behavior, if that answers your question.
Okay, yes, that answers my question. Thank you.
Now, I think one interesting point that Moots is bringing up in the chat, Dima, for you in particular, is that should we allow contracts to define initial rent balances? Because if we don't, of newly created entries, because this kind of has the same attack surface, or I guess attack surface isn't the right word, but perhaps the same accidental or purposeful misuse issue of exposing the rent bump function, but it's a really poor interface if every newly created entry just has the minimum amount of rent, and then you need to immediately do a host function operation after calling the create to bump the rent. So I guess what do you think with respect to newly created entries? And should we special case that even if we don't expose the rent bump host function?
Again, I'll try to answer quickly because Lee wanted to say something, but I'm still not sure if it's a good idea either. I feel like I should think more in terms of how can the contract user provide the needed rent bump, maybe as an additional fee, or as I said, like maybe some annotation and footprint or something. Because really, if you think about it as a contract writer, like you're writing a token contract, what should be the initial rent balance on a new balance entry? I cannot really answer this question for every user. I'm sure anyone can. So my intuition is that for entries where we actually want to ever bump the rent balance, it's highly likely that it's on the user to decide how much do they want to bump it. So yeah, I'm really not sure like how contract writers would define this initial balance in a sane way. That's my opinion here. So I'll say something.
Yeah. So first of all, I just want to say it is interesting that we are discussing like these multiple approaches to essentially automatic for the user bumping the rent. And I think whenever we do have like multiple things at play like this, we do have this potential for it to become very confusing for developers about, when do they need to get involved and do something themselves versus when can they rely on the automatic. So maybe just something to keep in mind, like if we are going to have these multiple approaches, that's just something we need to think about, that complexity. But to the idea of having, the contract do the bumping, it sounds to me like it's sort of owning two responsibilities. And we're talking about those two responsibilities together. Maybe we can split them apart. And so the first one is knowledge about the keys. And that does really sound clearly to me like something that the contract is responsible for. Contracts decide, what storage, how to arrange their storage. It's not really in the user domain to know that information. And so it does really make sense to me that, okay, a contract should be responsible in sort of telling a user somehow that, these are the keys that relate to I guess we sort of expose that already through footprints. I guess, you can look at the footprint from your transaction and say like, oh, I've affected these entries. And so, if I want these entries to live on past some future point, I probably want to bump them. And you know what the footprint is ahead of the transaction because you have to provide it. So, that's maybe an interesting thing we can utilize. And then the second part of the contract function is decisioning about how much to bump, or at least that's what I'm understanding, Garen, that uh, the contract would actually decide how much to bump. And that seems less clear to me about where the responsibility lies, because like I agree with Dima, like if I'm a contract developer writing contract or token contract or any sort of contract, I don't really know how long this user needs this data. You might be using the token contract for just this one transaction or for a short period of time, or maybe you're locking up an asset for a long period of time. It's really unclear to the contract developer. So I feel like if we can find a way to keep the decision about how much to bump in the hands of the user while not needing the user to have knowledge about the keys, or maybe using the footprint in some ways so that users or applications that users are using, uh, can use the footprint to discover those keys.
Yeah, I think one interesting thing might be like say like we have like this automatic rent bump and just allow that to be a user defined field in the footprint. So for instance, we could say like it must be at least 10 ledgers just for the health of the network. No one should be able to, avoid automatic rent bump payments. But then you can define an arbitrary number. Now the issue is I think that might be a little too not granular enough. So for instance, say if I'm creating a token or creating a balance for the first time for a wallet and I want it to last 6 months, I say, okay, I want my default rent bump to be 6 months. And so that would handle, all the keys I touch in the creating of that new entry. But if we just have that one number to encapsulate everything, I would also be bumping the WASM by 6 months and the contract instance by 6 months because I touched those two as well, which is probably not what the user intended. And so I think I kind of agree with how you put it, that there's knowledge of the keys, that's the contract responsibility. And then there's the knowledge of how much you want to bump, which is a use case specific thing based on the invoker. And the issue is like, if we just have one parameter that for the default rent bump, that doesn't encapsulate knowledge about the keys. But then the issue is if you want to have define a rent bump for every key in the read write footprint, that again is putting essentially like the knowledge of the keys on the invoker again, which is kind of something we want to get away from.
Well, yeah, I mean the invoker is potentially multiple parties because there's the user, to the consumer, the end user, and then there's an application that they're using to interact with the contract, and that application they're using could potentially make some sort of broad assumptions. Maybe for token contracts, an application developer might be able to handle their granularity. Like as you're pointing out, they might be able to identify, okay, the balances look like this. Have this key. Maybe it doesn't really extend well to other contracts though.
Yeah, so I guess. So I don't know. Do we have any like key takeaways then? I mean, because I agree that I don't know. I just feel like the barrier to exposing the rent interface to users can be somewhat high, and I don't know if it's a good interface. Now again, like this might be acceptable if like people are interacting with the network primarily through wallets and sophisticated kind of L2s like that. But I don't know, it just seems like a high onus to put on the user to essentially have to invoke periodic host function operations in order to maintain state that they are accessing through smart contract calls. It just seems like the most reasonable interface for the caller of the contract is for the contract to take care of the contract state.
Is it possible that we could find some okay, so I agree with what you're saying, and so I'm wondering, when we discover what the footprint for contracts are, I wonder if there's a way for us to include with that some sort of, this is what the contract recommends you use. And maybe this might get too complicated, but if a token contract could say to a user, this is somehow defined, like this is the recommended rent bump for my contract, but users are still in control. Or maybe that's pointless, because then everybody's just going to do what the contract says, and we're essentially building something that we don't really need the flexibility around.
Well, maybe what we could do actually, say, actually, okay, I think the best of the both worlds is we want the contractor to be able to define the keys, and we want the user to define the amount. So maybe what we can do is, instead of having the footprint parameter be the global footprint bump, what we can do is we can define a new parameter called auxiliary rent bump. It's just a single value inside the footprint. And then I guess we could expose this to the smart contract in some way. And then the smart contract could call the rent bump host function, but the value of the ledgers to bump must be the auxiliary value provided by the user. And so I think this still has some potential gamification or griefing if the contract would use that to bump keys that are not relevant to the user. But I mean, I feel like that's a class of bug that just needs to be audited. And I think that's kind of, there are many smart contract bugs that fall into that area. But then I think this might provide you like a good middle ground where the contract can still say what keys need to be bumped and the user can supply the value. And so say this value could default to 0 just for safety reasons. But then say if a user is accessing their contract or their token wallet, they could say that I want to rent bump by 6 months. Everything that the contract deems should be bumped, which they signify by calling like this auxiliary rent bump function inside the smart contract. Thoughts on this approach?
Yeah, I think something like that. I think something like that could work pretty well. And either presenting that how you just described, as you just provide one value in the transaction, or maybe you could actually just provide a value next to every footprint, which they'd functionally work the same way, but it would give you a little bit more flexibility for some power use cases where maybe maybe a power user is wanting to specify explicit footprint entries as having more. But I think that idea does start to shift the responsibilities into the right places.
Yeah, I'm not necessarily against the footprints, and the only thing I'm wondering about is how much more useful it is than, say, separate host functions that does the same, plus some maybe metadata on the contract. I'm just a little bit worried about mixing a lot of things together, right? So you have a transaction that does something useful, like a payment, for example, right? But then we also have this another completely unrelated operation, this transaction, which is bump rent and the relevant entries by time, like by time periods that you have defined. So does it really need to be the same operation? Or maybe it is okay to just have this as two separate operations that can be composed if needed.
Well, I mean, what would that look like then? Because I mean, I think the issue is the knowledge of the set of keys that needs to be bumped, right? Where I think I agree that like the per key approach could be good for power users. I still think we need like a one size fits all. I want to bump by this amount, because I could see from a user perspective saying bump this set of keys by 6 months. You have to define the set of keys and all that sort of stuff. But if you're sending transactions and be like, I want all my things to live for 6 months, so I can say send this transaction rent amount 6 months, and then the smart contract developers determine what is important to that user to fill into that auxiliary space. I feel like that works
Well,
for most use cases.
I
in
feel like
significantly-
again we are kind of mixing up what user is. Like, do people really like if you think about how smart contracts would be used, right? Chances are probably there is some tab that like some web apps that actually builds the transactions for you. Like where the rent should fit it. Like I'm writing, say, at DEX, right? Should I really expose rent bumps in my UI to the users? Like how it would work?
So I think that's a really good question, Dima, and I think there are two answers to this. I think there's one class of interactions that come directly from a DApp front end, and from that perspective, you're right. Like the DApp knows exactly what ledger keys an account refers to because it's the same developer who wrote the smart contract. There's another class of interactions that's like more generalized interactions. These happen um, either through like wallet interface, like general wallet interfaces, or they happen maybe through various compositions. Like I'm not using an AMM directly, but I'm using it through some sort of like an aggregator or through like a balancer um, contract that actually splits my liquidity between different contracts. So I think what you're describing, it like directly interacting with ledger keys, that only happens in like the one case where the origin of the transaction is is kind of like developed by the same developer of the smart contract, but that's not the general use case.
Oh, what I mean is actually not who knows the keys. What I mean is, what is the UI or UX for actually setting up the room? So let's say we go for this idea where you can somehow pass some additional rent balance as a part of your transaction that does something else. Then the question is, like, no matter like who knows the keys, how the user would actually supply this number. Like I really feel like this should be probably the wallet responsibility most of the time. That's really stuff that you need to bump probably has something to do with something you own, and this is something your wallet should be responsible for. So I'm not sure if it works well with the model where some other entities and wallet builds a transaction, because as I said, like you're doing something completely unrelated. Like especially when you're talking about some more complex routing scenarios, right? How would you even expose some rent bumps to the user? Like it just seems very arbitrary. Hey, you're about to trade these tokens. Hey, how about bumping some random ledger entries? I don't know. Doesn't seem like the right UX to me, which is why I was kind of arguing about this idea about just having a standalone process for this, which I agree has its own issues, but at least the user story is pretty clear here that hey, you have a wallet, for example, and it monitors your balance lifetime where it matters. I don't know. Maybe I'm missing something fundamental about like how things work, but it just really seems like two different things that we want to bundle together in the same transaction, and one of these things is not completely obvious to that main use case.
I think regardless of whether we bundle it or not, the problem that you're presenting, who's responsible for it, does the wallet just do it for you? That problem exists. So if we bundle it, the problem exists. If we don't bundle it, the problem still exists. And to Thomas' point about the different use cases, and your point about would wallets just do it, I think that's fair. Like consumer wallets are probably going to make some default decision around you want to have 6 months or a year for your balance, and then you can recover it from the archive. And it's those other power users that are maybe going to, or those other composition use cases where the rent is going to become more interesting, because maybe in a composition use case you don't need that balance to have a starting rent of 6 months. That's might be a waste of fees. Maybe you only need it for a day.
The thing is, like for the walled example, I think the issue is that if we don't define, or if we don't allow contracts to define rent bump behavior, the issue is token or wallets speak ERC20, which is an interface, whereas rent bumps aren't an interface issue; they're an implementation issue. So two different tokens could both be ERC20 compliant, but implement ERC20 in different ways. So token A might have 2 entries you need to bump, whereas token B just has 1 entry you need to bump. So I feel like just kind of saying, oh hey, the middleware software is sophisticated enough to know how to bump. I don't know if that's an assumption that can be made. I mean, I think we'd essentially, like for wallets, we'd need like an ERC20 rent version that defines rent behavior in a way. Because I feel like I just think that just like the key structure is just so integral and so implementation specific. I'm skeptical of leaving that up to anyone other than the contract developer.
I think there was an interesting question from Mutz in the chat regarding something like a liability balance. And I think another angle we haven't been talking much about is whether in some cases the rent payments are needed at all, because, well, entries can be unarchived. And in case of this liability balance, for example, yes, it's maybe not in the user interest for this entry to live long in the ledger. But if you're using the unique storage, right, it shouldn't be possible to at least recreate this entry, which the contract developer could leverage. I'm not really familiar with this liability balance use cases, like how to force the user to actually pay your liability, but if you want them to continue your contract, you can just benefit from the unique entry. And it doesn't really matter if it got archived, right? Because it won't be recreatable and users just won't be able to reuse the contract. I don't know what is the other enforcement mechanisms. But basically, the point I wanted to make, it's probably not super bad if entries sometimes get evicted from the ledgers. This is kind of by design, especially if it's rarely accessible. And the downside hopefully isn't that huge. So probably, while we are talking here about how bumps work, we should recognize that, we should make sure that the UX for actually restoring the entry in ledger is sane enough so that even if you kind of mess up the bump logic, you still not in too deep of a trouble. Which I don't know if I'm missing something else for the liability use case.
In the liability case, the liability still exists, right? It may not be on ledger because it expired. And anyone can recreate it. So I don't know if it's is that an actual concern, right? As long as you understand that the liability is there, like you could anyone can recreate it and put it back into the ledger.
Or I think recreate's not the correct word here, but restore, because like in the example you gave, essentially what would happen is if it expired and a user tried to do it, it's if you use the unique storage interface, which you should for this particular use case, then the contract knows that the thing is in the archive, because that's one of the benefits of unique storage, is that it essentially provides information if the entry is in the archive or not. And so through the unique storage interface, you know that the liability exists somewhere. And so the transaction just fails if the liability is not live because you can't check it. And so I don't think there's a security risk in the rent, because I think rent should never be used for like lifetime management or something like that. That's a temporary entry concern. So I think like concerns as to like expiration are handled via the recreatable and unique interface. Rent is just more of a convenience factor, because how you pay rent shouldn't have any functional differences. It might just make your operation slower if you need to go restore something. But I think high level here, I think kind of what I'm understanding is we probably want to investigate rent information in the footprint. I think whether that looks like a per key rent or an overall rent bump or something like that is still TBD, but I think if I understand correctly, that's kind of DEMA that kind of like, I don't know, fulfills your not allowing smart contracts to game the system, but kind of still allowing smart contracts to define some behaviors that, or I guess investing in something in the footprint, is that kind of the idea we want to go forward with on this issue?
Yeah, as I said, like I'm not necessarily against this. Like I see some issues with this approach, but probably it makes more sense than just asking contract developer to write the manual bumps. It's both complicated and also error prone. Yeah, and I think we really need to think about the initial balances. So, like, even though, as I mentioned, like it might be kind of problematic to define it in a general case, we should think about what is the sane default value we are using, like even if it's not customizable, because it's kind of an interesting problem as well, right? Like you don't want to create an entry that lives like for a really short period of time, but you don't want to overcharge users.
Well, we actually have a implementation specific value for this, which is I think at the bottom of the rent proposal, just based on the structure of the bucket list and how archiving works. Minimum rent balance has to be enough rent for the entry to live into level 6, which I believe is 4,000 ledgers. And so we can make the default higher than that, but that is the absolute minimum. Just from an implementation standpoint, the minimum has to be at least 4,000 ledgers. If that value is too low, then if I think that's 4,000 times 5 seconds, I think that's like a day or something, maybe 12 hours. I don't know exactly, but I mean, if that's too low, we can increase it, but we can't go lower than that.
Yeah, but that's kind of interesting, right? Because if you think about something like a balance, you would think like about months of life, and 5 hours is like way less than that. So
yeah, that's what I'm saying. Like,
I guess we'll need to see what the actual prices will be, because it seems really counterintuitive that the entries that are kind of supposed to be permanent entries in the ledger are at the same time very short-lived, because we hopefully will be able to create temporary entries that are alive for, let's say, weeks, right?
But at the same time, I think there's also a valid use case for a quote-unquote short-lived. For instance, like if I just want to initialize a cold store wallet, I like initialize it, transfer $1 million USDC, and then don't want to use it for 10 years. I mean, it makes sense to just give the minimum rent balance, pay that, and then let it go into the archive, because I'm not going to use it for a while. So I think that there's still, I think keeping the minimum low probably provides the most flexibility. But I guess kind of what I was imagining from a functional standpoint is you would probably want to just create all entries with the minimum rent balance initially, but then be able to essentially like bundle and immediately rent bump was kind of what I had in mind. From an implementation standpoint, that'd probably be easiest. Now, if we don't provide a host function, or if we don't provide a footprint approach, that becomes challenging because you essentially have to bundle operations at that point, which I don't think would be really possible to implement. You'd have to implement that not in the Soroban, but somewhere else. But I think if we have some sort of footprint approach, I think that would probably be the best way, is just to default initialize every restorable entry with the 4,000 ledgers worth of rent. And then if the footprint defines any additional bumps, provide those bumps via the footprint interface.
Yeah, I think that sounds really good. I just to lean further on it, I do think I assume we're still talking about the contract still is the one that can do that auxiliary bump. So ideally, in the best case scenario, the contract developer has given this thought and they're acting in good faith. Sorry, they're doing the right thing and they're just using that auxiliary bump for the records that need to be used. So they might not auxiliary bump everything. But the worst case scenario is that they do they don't really think about it, and they do bump everything in the footprint. So as a user, you do sort of have some boundaries in place. It's not like a malicious user can do lots of damage. They can at worst only bump everything that's in the footprint, which would be of limited size anyway.
Yeah, and in the case that the contract is malicious, then like a power user, or if a power user just thought they knew better than the contract, they could always just set their auxiliary bump to 0, and then even if the smart contract tried to bump everything in the footprint, you wouldn't be screwed, and you could just essentially get around the auxiliary behavior if you had motivation to do so. I think. Oh, sorry, Tomer.
No, I just wanted to say that I wouldn't put too much effort into protecting against like malicious smart contracts. If a smart contract is malicious, there's like plenty of other ways that it can screw you over. And so trying to protect against malicious smart contracts or trying to protect against like buggy smart contracts is, it's a fight you can't win.
Yeah.
I actually
Yeah, I
don't.
think that's. You go, Demo.
Yeah, I wanted to say I don't fully agree with this because really, if you think about HOS, like any token operations need to be explicitly signed, and like my concern about all this customizable bump stuff is that basically you kind of are doing very implicit operation on a token, which is much harder to interpret. Because other than that, really things that kind of can impact the user are probably authorized explicitly. While here you have something implicit, which is why I'm more concerned about that than about the contract, say, just trying to withdraw like 100 XLM from you for no good reason, because that's at least very easy to trace and explain. Whereas, like, if you're paying rent for something, you shouldn't be paying rent for. Much harder to evaluate. Yeah,
Maru,
I'm not saying like we should be able, like I'm saying we'll be able to prevent everything, but I wouldn't just dismiss this saying we cannot do anything. I think we kind of can try to be a bit more conservative here.
I mean, like, it's not like you're signing a transaction, this is coming out of your wallet. I mean, all of these fees are coming from refundable fee, right? Like, even if you do like the, auxiliary rent bump, that auxiliary rent bump is still coming out of refundable fee. And so you have an upper bound, right? And so I guess feel like if a contract is malicious or buggy, I mean, you pre-fly it and you're like, oh wow, this refundable fee is like absurdly high. You're not going to submit that transaction. And so I think because we kind of have like this safe bound, both if we provide a parameter in the footprint to define the amount of bump to rent, that's one bound, plus just the amount of fees you have is another bound in refundable fee. So I feel like those two things bound the damage pretty well, such that I think that the rewards, the UX rewards outweigh the potential drawbacks just because it's so bounded and because it's fee based and not token based.
Yeah, I mean, if we expose this refundable fee in an explicit fashion, then I agree it kind of limits the impact.
Yeah, just to be clear, all rent payments come from a refundable fee. Both the automatic payments and the auxiliary rent bump host function would also draw the funds from refundable fee. Cool. I think
Just responding to Toner's comment about, let's not focus too heavily on malicious. I get it. I think this design does lend itself well to just to separating the responsibilities, so they land on the parties that are best equipped to handle those responsibilities. The fact, and I think just naturally out of that, we get a slightly better story for what can a contract do malicious for you. But I don't think this is really fully solves that problem, like you said. So, and nor can we.
I mean, I
But
think
it puts sufficient boundaries in place that any sort of malicious behavior wouldn't be outrageous.
so. I think we probably have a pretty good feel of the rent bump issue. if there are any final comments, I think we have like 10 minutes left if we want to move on to a second topic. Any last parting words?
So we don't actually have a second topic for today.
Or I
did
mean,
wanna
I mean
say-
a second rent topic. I mean, sorry.
Oh, okay. There's a second rent topic.
And then the third and the fourth. Sorry.
Yeah, I think like it's very clear that it sounds like in terms of like implementing and move forward, obviously it's the bumping by ledger key is a building block that we need anyway, so we can keep implementing in that direction. And it does sound like we need to potentially like enumerate all the options for how the contract exposes more fine-grained information about what ledger keys are actually associated with an account, whether it's through the host function you described, whether it's through the ledger footprint, maybe it's even just I don't know, like an ecosystem standard for, there's a function you can call that gives you all the ledger keys that are associated with an account. So I think we just need to like enumerate over all of these and probably like revisit them.
No, I think that makes sense. I think we probably need to iterate on this design a little bit, but I think we have some good building blocks from the conversation. Now, yeah, so I guess we don't have a ton of time, but I'll just introduce this. Kind of the second rent related issue, and then we also have a temporary entry related issue that we won't get to today. But for rent, there's also an issue of outstanding rent balance when things are deleted. So I don't know how often this will actually come up in practice as to entries being deleted with large amounts of outstanding rent balance. But initially, it seems reasonable to refund the rent balance to the invoker of the delete operation. This kind of provides network incentive to delete entries, which we do want to have because we want, if an entry is not going to be used, we want to provide incentive somehow for it to be deleted before it hits the archive, because once it hits the archive, it's stored in the archive indefinitely, or until restored at least. And so to keep the archive size small, even though it's not as big of an issue as having a large amount stay on the ledger, we still want to incentivize deletion. The issue is, if you provide rent balance refunds on deletion, you open the door to some sophisticated attacks and to some kind of patterns. So the issue is that even though many different users might be contributing to the rent fund, or many different accounts might be funding the rent balance, only a single account redeems the rewards when it's deleted. And especially since we are defining this automatic rent bump at the protocol layer, this could open the door to some interesting attacks. So for instance, say you have like a contract that's used very often, like an AMM or a big DEX. What they could do is they could just touch one key on every invocation, and it could have like an innocuous name. It could be called like auth entry or like auth check or something like that. Something that would be difficult to detect in the code auditing. And then they could just like essentially have 10 XLM or whatever, like, or 10 ledgers worth of rent, or the minimum rent balance just continually be added to this object. And then periodically, the admin could then call an admin function that just deletes and recreates this object, essentially getting all the rent balance. This is kind of a malicious attack, but even a non-malicious attack, you could imagine where many different users are contributing to like some swap or something like that. The swap has a large amount of rent, and then whoever like liquidates the swap or liquidates or drains the liquidity pool and deletes the entry can also get this additional rent balance that was paid for by many different users. And so because of these two issues, it seems that we don't want to refund rent balance on deletion, but just have any outstanding rent balance be burned whenever you delete something. That doesn't seem like a great interface, but there doesn't seem to be a good way of refunding rent without running into these weird edge cases that can be gamed. So I guess thoughts in general on rent refunds, and if we should think about this in a different way.
Just wanted to mention that we have considered an alternative where we would record which account has created the entry and then refund that account. But besides the fact that it doesn't avoid all the possible issues, the problem with this approach is that it's really like adding a significant amount of ledger space and it's not obvious whether the additional fee incurred by the fact that you are writing bigger entries will be offset enough with your refunds. I mean, we have discussed this in a bit different context, but I think it still applies here. Like, we are increasing entries sometimes quite significantly, and we want to refund some amount, so it's not clear if this is net positive or not, which is why that's probably not a good option.
I would also say that the that particular alternative was in the context of temporary entries, which have a single payer. I don't think that approach would work in the restorable entries with rent balances, because many different users, in addition to the user that created, could be paying into rent fees. So, for instance, you can imagine like the contract admin created the entry with a minimum balance, and then every user of the contract bumped it up to a very high state or to a very large amount of rent because it was used frequently and touched frequently. It doesn't make sense that the outstanding balance should go to the original creator who only paid minimum rent. So I think in the context of temp entries that works, but it doesn't really work in the restorable entry context.
Yes, that's kind of fair, but also I wanted to say that we do not allow deleting contracts currently, and I don't think we will. So,
or this is for contract data, not for contract instances.
Right. Yeah, but yeah, I imagine like the most common shared data is really the contract instance. But yeah. Anyway, I just wanted to say that the alternative was out there, and yeah, as you said, it doesn't solve all the issues, and it also has a significant cost attached to it, which is why it probably won't go with this either. Yeah.
I guess, are there any objections to burning rent or outstanding rent balances? Because it seems on paper to not be a great interface, but I think it's probably the best and most fair way to go about things.
Garen, how is this handled in other networks, or is this just in the context of state expiration?
This is just in the context of state expiration. No other network has like rent balances like this, so I don't think there's really any pre-context or.
Right, but on the EVM, you do get a refund for clearing space, right?
Yeah, so you'd still like get base reserve back and stuff like that.
Yeah.
But I think it's difficult because, I mean, on the EVM there's still like one pair, and then the refund is relatively small, whereas here the rent balance could be a somewhat significant value, potentially, and there's also multiple payers, which complicate things a little bit more.
Okay. So I think we're at time, and obviously, I think we all need to think about that some more. So maybe start a thread in Soroban Dev on refunds, and we can revisit that later.
Sounds good. Well, thank y'all.
Okay, we're at time. Thank you all, and see you next week.